audience in the room. Oh man.
I can leave. Or you can.
Yeah, I can. Now that the pizza is here, you don't need me anymore. All right, let's go ahead and get started. Welcome to the June 2014 Hackformers edition, or the educational meeting. Who Hackformers is? I see a few new faces of the benefit of those who are new. Welcome to all the old folks who've come in. Actually, not the old folks who've come in. All those who've been attending Hackformers.
They resemble that.
No pun intended for anyone here in the room. And for those of you new, Hackformers, who we are and what we do. Actually, the word Hackformers come from the word hackers, who are information security professionals, essentially, and then we're transformers or commissioned Christians, with the mission that God has given us to do while we're on earth. Our mission is very simple. It's to teach security, to teach Christ, and to teach security that is in Christ, the ultimate security that matters. And who we are not, we're actually a Christian organization, not a security organization, not the other way around. We're not competing with any of the local interest groups, so we're actually inclusive of all the local interest groups. Actually, we've been very blessed with having OWASP and ISSA and AHA and other organizations here in Austin that support and who work with us in kind of being alongside us. We're not competing with any other organization as well, so we're actually augmenting the local churches too. So just so you have that in mind. The way we operate is very simple. It's a monthly education meeting where a speaker is present on an information security topic. We draw a parallel from that topic to the scripture, in this case the Bible, and we discuss how that applies to our personal life. So for example, if you were to take the talk that I gave last was on cross-site scripting, a security perspective as well as a scriptural perspective. And for those of you who are familiar with cross-site scripting, you would know that it works with the principle that the output itself, when not encoded, ends up becoming, something that could hurt us, something that is harmful. So all output is evil, is what we would say, unless it's encoded. So, and then the way we tie that to the scripture is the Bible. It says that what comes out of a man, right, is what defiles a man. It's not what you take in, and out of the heart comes all of the, the devices of the world. So the Holy Spirit of God who's in us is the encoder that can render good the things that are inherently bad in us. And so the way that applies to our personal lives is you actually encode your response when you talk about security, and in our personal lives is the Holy Spirit of God, someone rendering harmless all the evil that is within us, so that we are truly His servants. So we also have a Twitter account which is @Hackformers, and then there's a blog that you can subscribe to. So most of you are familiar with the @Hackformers. If not, I recommend or I request that you follow. Some of the resources, there are some Bibles in the back that I would like you to take one. If you don't have one for knowing more about Christ, it's free for you, and so the Word of God is free for you to take and use to your advantage. The website we have is hackformers.org. You can also subscribe by email. We'd actually recommend that you subscribe by email, because anytime you put a post out there, then it automatically comes to your email. There's a LinkedIn group, Twitter, who's not a follower here. Right, so the way I would say is we follow Hackformers as Hackformers follows Christ, right? And there's a store as well that is set up where you can get some swags. There's some books, some bags and T-shirts. I have some stickers with me. The 2 stickers that I have, if you are interested, it's free for you to take. There's one which is the short square sticker, and then there's one which is longer that you can add. This actually fits in the back of your iPhone as well, so it's kind of made to that dimensions. The way I actually use my sticker on oops.
Oh, boy.
All right, that should work still. Is on the Apple, and of course I kind of am brand violating, I think. In any case, the idea behind the sticker on top of the apple is simple, right? Man fell by eating a fruit, right? And you need the cross on top of the fruit for us to be saved. So the cross of Christ, so that's kind of the idea. So Apple, no offense to you, although we are in a Microsoft building talking about it. I'm not sure how this is going to go. Make sure you edit. Janice, make sure you edit that before you put that. And then there are business cards as well for you to take, with you if you want to give. The business cards are kind of, if you want to kind of share about Hackformers, the way that works is, it's got nobody's name on it. It's just a business card, Hackformers, and it's got the mission on it. On the back is a QR code thing that they could actually links back to the website. Trust me, no malware, nothing on that website. Just so you know.
From the government?
It is not from the government, no. And you can actually write your name and your number if you want to pass this on. So make sure you take one if you want one. The store I was talking about has got some swags that you can look at. We are coming up with some ideas to print for upcoming conferences. So if you have an idea that you would like to have printed on a t-shirt, please let us know. And then, it should have the Teach Security part and then the Teach Christ part in it. And so please let us know and we can, put that up on a t-shirt. Ideally, I'd like to get some t-shirts out before DerbyCon, which is in September, so we can, use that as a means to be able to support organizations like Hackers for Charity and other organizations like Hackformers itself. So the ways that you could get involved is to pray first about the organization, pray for us, pray for yourself as you participate in it. Your time is one thing that we would like you to invest. If you have time to volunteer, especially with the promotion of Hackformers through, of Christ behind Hackformers through the tweets and all that. And then if you have, if you want to help with sponsoring some of the food costs about $50 to $60. I'm going to actually, I think, Vern, who's got the sign-up sheet? So for the next for God's grace, we had like 6 months of sign-up already done. One is passing out a sheet. If you feel led to sponsor one of the meetings, then all we do is you basically will give you the head count for that meeting. Like a day before the thing, you would call up the pizza store and then order it. For most of you have done this in the past, so if you feel like you want to help out with these upcoming meetings. I've also put the names of the speakers alongside, so if you have interest to see somebody who you want to sponsor, then feel free to do so. You're not obligated to in any way, but you're welcome to. And then your talents, if you have any, please let us know and we can use within the organization. So, announcements, next month meeting is actually not going to be the first Friday, but it's going to be the second Friday because the first Friday is July 4th weekend. So we'll have it on July 11th. I'm most likely going to continue my Kali operating system series within the Hackformer space on that in that meeting. And then we have a few other speakers that are confirmed and some that are potential I'll be working with. Michael Farnham, who's the QSecCon's founder from Houston, Ed Scoudis from SANS, Michael Hubbard from Microsoft, and then the president of Offensive Security that built the Kali operating system, Jim O'Gorman. He's planning to be here in November. So, and then I'm actually also happy to report there is interest of local Hackformer chapters in different parts of the country, and so hopefully we'll have one that will come up soon. And Indianapolis is the next one that we're looking at. So we don't know what God is leading and how He's leading, but we know that He's leading, and so stay with us in prayer, and we'll see how that happens and how He leads. So with that said, I'm going to actually call upon our speaker for today, Dr. Jared DeMott. I call him Jared, and you can call him Dr. DeMott. Jared is very well known in the world of security, but really what intrigued me is when I met him first time in DerbyCon, his simplicity, his humility, and just his belief and his faith behind who he is as a Christ follower that appealed and that was attractive. So Jared, in fact, has taken the time and has invested to come from Michigan today. So unfortunately, we have a few that are not being here because of other X Games that is going on, and there's a rabbit show in East Texas, I believe, that that they're going to.
That's the reason.
That's and other things. But anyway, they're spending time with the family, which is a good thing. So I wish they were all here as well. In any case, so Jared, without further ado, let me give him the floor, and he's going to come and talk to us about things that matter. And I'm going to leave these stickers here. There's more stickers for you to come and take as you need them. So.
Before a date?
Yep.
Yes. I'm not exactly sure how that ties in, but we were talking about some different S's about security and being spiritually fit and all these different things, and just I don't know, somehow this 3 S's theme. Yeah, this is great. Thanks. Fine. Came up, and I thought it would be kind of just a funny way to start a talk. So I got some funny pictures. Hopefully you'll enjoy them and kind of get into a more serious learning about application security, as well as how that might tie into our personal life. So that's kind of the overview. I guess I just said the agenda. So in terms of me, I'm Jared. I'm from Michigan. That's where I live. I've lived and worked remote from my house for 9 years now, I guess since 2005, for various companies in the defense industry, and now I work for a startup company out in California. And I've done a lot of speaking and writing and researching. I was lately, early this year, researching on how to break EMET, which could be, I won't bring that up too much since we are in a Microsoft building, but That was actually some really good research, and I think it actually helped. What it really did is it helped improve on it, because when I published it and we talked and we made sure that we provided our research ahead of time to Microsoft and stuff like that. They were actually, at the same time I released my How to Bypass 4.1 findings, they released a 5.0 tech briefing in February this year, so we kind of had coordinated that a little bit, and that worked out well. So, anywho, enough about me.
Jared?
Yes.
It's at JaredDeMott, right? It's your Twitter
yes,
handle?
yeah, Twitter is at JaredDeMott. I have that at the end, I think.
Okay, just in case if anybody's tweeting during your talk, then that's the handle to
At
use.
JaredDeMott, that's right. I figured everybody is like live tweeting everything now instead of actually listening. I should just, yeah.
Right.
Yeah, I think I saw Charlie Miller tweeted out yesterday that he wasn't sorry that he was going to miss SummerCon this year because he knew that Chris Ng was going to tweet it live the entire time anyway, so he was just going to be sure to check his Twitter, and then he'd essentially be getting SummerCon at the same time. So it is kind of interesting how that's changed. You know, I don't feel like I'm that old. I just turned 36, but I feel like already in my 14-year career, I've seen a lot of change. I mean, people weren't doing this even 14 years ago, live tweeting a conference. People were just at the conference. Like it's very much changed now. So anyway, what are the 3 S's that you should do or be a part of? Oh. Okay.
Do you mind if I switch it now?
Yeah, no, yeah, that's fine.
'Cause
I
I-
just saw you changing something. I was like,
I'm
oh,
just,
no.
I'm just getting
She's changing
the focus
it.
off you.
This could be bad. Okay, so is it these items, that item, and that item? No, that's not what I had in mind for this talk. Although I guess that is 3 S's. That's commonly thought of. Yeah. Now, more relevant to working professionals, the sort of the trappings that we get caught up in. The 3 S's are success, and then of course this item as well, and then sort of making sure that you're doing everything you can to sort of protect your nest egg and everything else. But that's not really what I had in mind either, in terms of where I think I want to spend my time. So in terms of how I want to prioritize myself, I'd rather spend time in service and sacrifice, and of course being concerned about our salvation. So now that you know kind of where I stand on those subjects, how does that actually relate, if at all, to information security? One reason that it definitely relates is the fact that InfoSec is not really strictly a technical issue. I mean, if there were no people involved, there wouldn't really be that much of a technical security issue, right? It's because we have people trying to break in, or we accidentally write bugs, or whatever it is. So it's very much a people issue, really, when you think about it. Even though as technologists, we get very concerned about the technology. So that's what I'll be talking about, is the technical stuff. But I want to keep in mind, and kind of come back to this at the end, that there's a very human element to that. So. In the spirit of Microsoft Pictures, here's one that comes from Microsoft's SDL, their Security Development Lifecycle. And so the little red dot is you are here. I guess you're in training right now, sort of. And so I'll show one of those on every one of my slides. And I thought what I would do for my talk is, instead of just deep diving, because I could talk for hours on any one of these topics, whether it's fuzzing or auditing code or static analysis tools or attack surface design review, whatever it is. I could go in detail, but I only have a shorter amount of time. So I thought what I would do is give a small piece of each one of these. I got a small demo on fuzzing, and I've got some code to look at to audit, and to just get a flair for how each one of these activities kind of works. And keep in mind that it's not necessarily a perfect flow like that in real life, right? Like, I mean, I actually do some of this work for a company, and sometimes you might end up doing this before that or whatever. So there's a little give and take, but it gives you at least some sort of overview in terms of how your security, in terms of your development process, could be. So one of the things that I've heard a lot of higher ups in kind of the application security space talk about is kind of moving security to the left. So not just trying to blaze it on at the end, so to speak, but moving it all the way to the requirements and the design review, and so that's something that I think every organization should be thinking about: hiring the right people ahead of time and making sure that already have a plan for the fact that you're going to do a pen test at the end, and all that kind of stuff. Having kind of thought through this process, growing in maturity, just like we're growing in maturity, your development process should be growing in maturity. And one of the ways you can do that is by thinking about ahead of time, what kind of app are you developing? Is it, sort of low importance like a cafeteria menu? Maybe it only needs static analysis tool, some automated tool to check it, and then it's fine. If it's, B2B, maybe you need both static and dynamic. You have to fuzz it as well or do some other, runtime testing. And if it's, some desktop product like Word or something, it's of sort of high importance and it needs not only all that, but other types of manual audits and pen tests and stuff as well. So there's tools that you can download and play with, which I won't go into detail. So I'm not going to spend a lot of time on all this sort of higher level stuff. I'll spend more time on the technical bits, but I wanted to at least talk about it, introduce it. So what's wrong with this DFD? It's data flow diagrams. Anybody seen this one before? It comes from the white Bible of AppStack. There's The Art of Software Security Assessment. Have you guys heard of that book or seen that book? This comes from that. It's the big, thick, giant book that you could kill somebody with if you threw it at them. Is there anything, if you've already read it, the book, I guess maybe you remember this part, but if not, is anything that could be better, I guess, about this? So this is like a web app, and basically you're just kind of logging in and then presumably doing whatever it is you're doing. So really the only part of the attack surface that's being modeled here is the login portion. And
yeah, the problem is all the credentials were submitted on the login to an HTTP protocol. So it was all unencrypted, and in the middle attack is now possible, all sorts of problems.
yeah, so there could be issues with that, although ideally I think what they're trying to show with this diagram is if you try to come through HTTP, you'll get redirected to an HTTPS, I guess. So that's not the one I'm necessarily looking for here, but that's definitely a,
How about two separate answers to why you didn't get logged in?
That's the one I was looking for, right? So you have an enumeration, a brute force issue. So you're being explicitly told whether it was the user or the pass that was wrong in the login attempt, which really you should just get one. You should get something more like this, where it just says login failed. So that would be a better high-level design of that application, right? So that's kind of the idea behind some of the early phases of security associated with your development. You can do all this before you really ever start kind of developing and moving forward with your plan, right? Okay, so assuming that you've done all this early stuff, you've done the best you can to design your software securely and all this kind of stuff. What are some of the, as you're writing code type methodologies, tools and techniques, processes? The three that, from a high level that come to mind are static, dynamic, and manual. So the static is kind of the automated tools, and they kind of, what they're great at is sort of bringing the whole product up to a certain level. So like you say, I don't want any stir copies or something in my product at all. Like you could do that kind of, you could do it in other ways too. Microsoft has a ban.h file that will basically disable your product from compiling if you so there's always different ways you could do this sort of thing. But that's, and they do more than just, exclude certain functions, of course. Any sort of, well-known buffer overflow, we'll see some examples that you might want to avoid and stuff like that. But they're definitely not going to find everything. And none of these approaches do, which is why you kind of want to use all three if possible. And so fuzzing is more about, and we'll talk more about each one of these in detail, it's more about hammering down the attack surface, right? So the actual interface that somebody sends data to that parses data or whatever. Fuzzing's all about, grinding away on that with all kinds of anomalous data. And then, of course, manual audit is actually going through either the whole thing or just portions of the code base. And so each one has, you could argue about the costs and stuff. Each one could miss bugs. The automated code scanning probably has the worst issue with false positives because it's got all these heuristics and it kind of spits out a list of bugs, right? And not all of those are going to be true bugs. So there's probably the worst issue there, where fuzzing is more, it's going to miss more code, so it's not necessarily going to scan as much. It's really just going to be hitting the attack surface, and probably not even all of that, because most fuzzing tools don't go as deep as we want. I can talk more about that. So you're not going to have as much false positive issue, but you definitely are going to miss stuff too. So again, there's that trade-off. And then manual, you really shouldn't have too many false positives, but you can end up with all kinds of time-wasted things where somebody who's auditing the code says, hey, this is a bug, and then somebody else says, no, that's not a bug, and you go back and forth. And so there can be kind of like false positive discussions, which can be sort of bad for security because it takes just wasting time. So in terms of a high-level view of the static analysis tool, basically what you've got is you're putting in source code and rules, which you can tweak. So as you run it, and you're dealing with all the false positives, you can tune out certain things or tune up certain things. You can change. Most tools allow you to do that kind of thing, and then somebody's obviously got to review those findings and then fix that code. So that's kind of the high-level view of the static analysis. And like I said before, they're going to be finding simple bugs like this. So this is just a simple, most of my experience is in C and C++, by the way, in case you can't tell from the code example. This is old C2, so I'm not doing as much with web stuff. But this bug would be called a stack buffer overflow. You can see that the old-fashioned way to exploit those was to just overwrite the return address, go back up to some NOP sled, and then slide into your shell code, which, interestingly enough, I don't know how many of you guys have done sort of, binary exploitation or whatever, but a capital A is actually a valid NOP too, because it's just I think it's like int EAX or something, just like changes one register or something. So you can go through as many of those as you want, really, without crashing the system. All you need for an effective NOP sled is just some assembly instruction that doesn't dereference memory, basically. If it just does some mood operation. So, and then this is an example of an off by 1, for example. We're going from 0 to 100, which is 101 operations instead of, it should be like less than. This equal should be like not there for that to be a valid code snippet. And this would be like a stack, a heap, because the memory's on a heap buffer overflow, not a stack buffer overflow. And this is kind of one of those cases where the developer maybe tried to do the right thing by using the N, the semi-state. It's not really the state version. That's actually banned in the ban.h file as well. But it's a safer version and stir copy. It's got the stir N, so it's got a length, but the length is arbitrary. That's from user input. So there's no check on the length as well. So that's basically, and I've seen stuff like that where they're like, okay, so I have to use the safe function. I'll just use it then however I feel like using it. So you can improperly use the safer versions of APIs. And then of course this is what's called a format string bug, which I don't have time to get into all the details of how they are or were exploited. A lot of these are sort of older, and that's the kind of things that static analysis tools are really great at finding, like known buggy patterns that have been known for like a decade. Those have all been finally put into those kind of technologies. Those, they're scanning for certain heuristics and stuff. And so then I'll get into some more modern code snippets, like those are the bugs of sort of yesteryear. What are the bugs that kind of today that those tools generally won't find because they're kind of too bleak. They're always like 3 or 4 years behind, it seems like, in terms of these are the cutting edge bugs for 2014. It doesn't find those. And it won't find them for like 2 more years or something like that. That's generally what I've seen. It's probably not always true. I'm sure there's exceptions to that, and people are accelerating that too. I think it used to take them like 4 years to catch up to find today's bugs, and now maybe it only takes them a year or something like. So I do. There's definitely some acceleration there, which is a good trend. And like I said, you could also get rid of certain APIs that are known to be malicious with other types of headers. Okay, so that's kind of the static analysis. So what about the fuzzing? So the fuzzing, again, for me, I've been working mostly on fully compiled code. So like system software, like a kernel written in C, or like a browser written in C++, or most of my security testing type, hacking, whatever experience is mostly on fully compiled stuff. So when people tell me that they're fuzzing the web app, I kind of cringe because I'm like, it's not really, because fuzzing, so if you look at this fuzzing diagram, what you've got a subject under test. So let's say that's a browser or something, and then you've got some fuzz master, which is creating malicious input. So that's maybe like generating malformed Word documents, and it's going to deliver them to Word or something like that, or to IE or whatever you're fuzzing. And then you've got like a debugger that's checking to see every time, okay, you deliver a new file to Word, you attach the debugger, does it crash, yes or no? If it crashed, why? Oh, because it tried to write or read outside of the bounds of some properly allocated memory. So then you dump that information to a database, and the database would basically be a series of the information that's put in there is the state of the process when it crashed. So the registers, the call stack, stuff like that. So in my mind, fuzzing is really generating sort of semi-valid, mostly valid input with different sort of heuristics and tweaks to the data to try to get a process to essentially die or crash. And you're looking to then, figure out, okay, can we exploit that? Like, oh, there's a call EAX, and I can tell based on the value in EX registers, x86 prefix registers that, we control that value, so then that could lead to an exploitable condition or whatever. Where when somebody talks about fuzzing a web app, you can totally use the same term. I mean, I don't have any beef or I'm not married to that term or anything like that, but like it's different. Usually you're like, when they say they're fuzzing a web app, they're actually like enumerating usernames and passwords or something to try to brute force log in or something. So I would call that enumeration or brute force, or so I wouldn't call that fuzzing. And I've heard a lot of people say like, I'm going to fuzz the passwords now or something. I'm like, it's not really, but it's like a sticking point, right? It's like splitting hairs, I guess. It's kind of a similar thing, but it's kind of not really at all in my mind. But I'm like, use the right, I don't know, whatever. So anyway, so I have a little demo of, in this case, fuzzing Internet Explorer with GIF pictures using the Peach fuzzing framework. And so basically, again, those same steps that you always need when you're kind of doing fuzzing is you're generating some input, you're delivering it to some application, and you're monitoring it with some kind of monitor, usually a debugger or something. Yeah, but it wouldn't have to be. There's actually, I've seen a lot of other interesting ways to monitor. You can monitor like with pings to see if a router crashed, if you're fuzzing something that you don't have access to that you can't get a debugger on or whatever. There's a lot of ways you could do that, but this is kind of the general methodology, I guess, anyway, from a high level. So let me flip over to a virtual machine here. I've got running. This has got Peach inside of it, and it's got everything installed. So actually, I don't know if I mentioned this, but some of this is kind of like the quick breeze-through version of my 2-day class. So I teach a 2-day class called Application Security for Hackers and Developers at BlackHat every year, and sometimes at other places too. And it's basically a full half day on all the what I call the 4 pillars of AppSec. So you've got a half day on fuzzing, half day on source code auditing, half day on reverse engineering, and a half day on exploitation. And so this is kind of just like a quick taste of some of the stuff that we would do during that class. Like we would sit down and write a fuzzer and run, and we would, try to write some exploits, and we would audit some code and find bugs and all this kind of stuff, right? We do it in a little more detail than I'm able to get into today. So, Peach, which I'm kind of fond of, I guess, sort of. I know the author fairly well, Michael Eddington. When it works great, it works great. When it works bad, it works terrible. I've had a lot of bad experiences with it, actually. Like, you go to do something, and you realize it doesn't do that, or it can't do this, or it crashes when you try to do that. So, like, it was for a long time a free tool, and I think they're kind of transitioning Peach out of free tool mode into kind of a paid mode. So I think it'll probably get better, actually, as that happens. But anyway, it works great for this kind of stuff. This is one of the simple, a simple sort of thing where you're just opening an app, you're monitoring it with a local debugger, and you're sending it a file and stuff like that. So it works great for file fuzzing. So what you have in Peach is all the sort of configuration to set up the fuzzers all done in XML in what's called Peach Pit. And the not the most important part, but one of the important parts that you are concerned of as the sort of fuzz engineer is what's called the data model. I don't know if you guys can read that well or not, but right now it just has what's called blob, which just means like all the data, it's just going to like kind of fuzz everything. So like if you give it a sample file, it'll just like randomly tweak a few bits somewhere, or it'll slide a DWOR through the whole file, or it like considers the whole file as one big blob of data. And so what you want to do to increase the intelligence of your fuzzer is actually change that data model to properly describe the GIF picture format. Okay? And there's a lot of different ways you can learn about the GIF picture format if you don't feel like reading the 200-page RFC. There's a cool hex editor called ONO Hex Editor, and it has these like built-in templates where it already understands a lot of protocols. It's kind of like Wireshark, basically, for files. So you open up ONO, you put in a GIF picture, and you apply the GIF template, and it sort of breaks it out as like the first 4 bytes are this, the next 6 bytes are this, the next 2 bytes are a link for the next 12 bytes, or whatever the format. It's like, to me, file format data is like pretty similar to like network format data. Like you send this, I send this, you send this, you send this, except for in a file, it's like you have the whole stream all together, sort of like, I don't know, it's just a stream of data that has a particular format, basically, if you think about it that way. So Peach has this tool called the Peach Validator, and it's also very similar to that idea of that O&O template. Once you know what your format is, so let me switch back, I'm getting ahead of myself. What I had done is I started with the simple template, and then I upgraded the blob. So in this version, So that's like what I have you do for one of the labs. I kind of give you like the starting piece, and I say now upgrade the data model to like be more intelligent about the gift thing. So this is kind of a result of after you've worked on this lab for a little bit, then you end up with something like this, where I went too far in, can't see the top. Like the first 6 bytes are GIF 898, for example, or something like that. So you tell it it's a string. You give it a name, you give it a length, you give it a type, all this sort of stuff. And then that allows the fuzzing framework to more intelligently fuzz that data. So if it knows that it's fuzzing a string, it has certain heuristics that it applies to a string. If it knows that it's fuzzing a binary D word that's a length that describes other data, it has certain heuristics that it uses, like it will send a length of null or all Fs, or like it has certain things, changes, heuristics, rules of thumb, that makes the most sense based on the data type. So that's kind of what fuzzing's all about, data typing, really, when you think about it. It's all about monitoring, it's all about data types, it's all about understanding the app you're going after. So, and then the rest of the so-called configuration of Peach bit is basically whatever else that Peach needs to understand this program, like the full path to your input sample is in the state model. The state model is kind of like, it defines the state. So like if you're fuzzing a network server, you send this, I send this. In this case, with a file fuzzing, it's like I open a file, I output to the file, I close the file, then I give the file to the app. It kind of defines the process of the state. And then the agent portion of the Peach pit describes the program name, the command line that you need to run it. And then there's also this page heap thing, which is really cool. I don't know if you guys have messed with page heap at all, as it relates to sort of system testing or whatever. But basically, when most operating systems allocate memory for some process, they, in the past especially, did it very, it was very regular in terms of how it did it. All the pages were together, and in terms of how and where they were allocated in memory. So like if you had say like a 3-byte overflow from one heap chunk to another, that may never get noticed as you're fuzzing or whatever, because it might just like overflow into data that never gets referenced through the rest of the life of the program. Or maybe it will crash, but it'll take like a few hours before it finally crashes later. And then when you try to debug it, you're like, oh man, I can't figure out why this app crashed. It's a really goofy crash or something like that. So when you enable page heap, what it does is it puts an unallocated page behind every allocation, so your process is going to run slower. So there's a trade-off. But if you overflow even by 1 byte, immediately it crashes. So you can find those sort of bugs quicker. So you generally, when you're fuzzing, you always want to enable page heap, and it's called something different on different operating systems. But on Windows, it's called page heap. And then basically a path to like a log file and the name of the output file that's fuzzed. So anyway, that's kind of in a nutshell. That's a quick demo of how to use Peach for file fuzzing. And then when you run it, you just type Peach and then the name of your Peach pit, and it'll start fuzzing away basically. You should see like Internet Explorer popping up like rapidly with a picture that sometimes shows and sometimes it doesn't show, just depending on what mutation was done to the image, right? It won't display every time. But every time it's logging those results, if there was a crash, we would end up with like a list of sorted crash. So it uses the Bang Exploitable plugin to the WinDebug. WinDebug has an extension called Bang Exploitable because the exclamation point is called Bang. And it basically helps with the sorting and severity rating of bugs, which is quite nice for this kind of activity. So, because you might find 1,000 crashes and then realize they're all the same. And so it kind of buckets them based on the call stack where it died at. You'll get a bucketed, sort of pre-sorted list of crashes, which is really nice if you're getting a lot of bugs. So let's see if I can stop this.
I have a question.
Yeah, go ahead.
The number of tests that it runs, is that predetermined or somewhat predetermined?
It depends on, in Peach they have what's called a strategy. So they have different strategies. They have kind of the forward to back strategy, which is basically for every element that you define in your data model, will apply the full list of heuristics to that element. So if you've got a D word and it's got like 500 different changes it makes to a D word, it'll do that. And then it'll go to the next thing, which is a string, and it's got 800 different permutations it does to string, so it'll do that. So you can actually figure out, if you're using that strategy, it's basically number of iterations times time for each iteration. Like if it costs you 3/4 of a second to do each iteration, you can actually figure out your runtime, which it was starting to do, I think, these numbers will eventually give you essentially an estimated runtime. So like maybe it's going to take 12 days for it to finish doing that or whatever. And if that's too long, you can actually run it in like a parallel mode. So you can start 12 computers and you can tell it I'm computer 1 of 12, 2 of 12, etc. and start that same thing on each one. And it'll like split those test cases so you can finish in a day instead of 12 days. So you can speed that up by doing that sort of a fuzz farm type idea. I mean, most big companies are doing that kind of stuff. Microsoft has been doing that for years, and Google does it. And all the big players out there are doing a lot of fuzz farming and stuff like that to make sure that. And they usually have some bug bar. That was in the whole SDL. I didn't really cover that, but it's like, you know, for this particular product, it has to pass 1 million clean iterations. In other words, it can't crash at all for 1 million iterations of fuzzing, and if it does, then it doesn't pass to like this sort of like, you know, release mode or whatever. We have to go back and fix the bug and figure out why and everything like that. So. Okay, so that's a little bit on fuzzing. Give you a little taste of that. So we talked about static review, or automated static analysis. We talked about dynamic analysis, which was now I want to talk about manual code review. I mean, there's so many different things I could talk about. You know, all these different types of bugs as it relates mostly again to C and C++, like returning a locally scoped variable is a bad thing to do because they only have a scope for that function. So if you return that to some other function, who knows what's going to happen? They're going to have a random pointer somewhere on the stack, which is going to be to like nebulous memory. So there's all kinds of these, and I don't have the time to talk about every one of them. Some of those are sort of, you know, older bugs that have been known for years, and then some of the ones that I want to talk about now are kind of the newer ones, like the use after free. You guys may have heard of this type of bug, but it's been the one that's hitting all the news lately. It's in all the browsers. All the browsers are plagued with use after free, and they're usually bad. They're usually exploitable. They're the next big, you know, Patch Tuesday, sort of thing. And the reason for that is because, well, first of all, how do they happen? As it relates, they could happen in many different ways, but as it relates to browsers, they generally happen because there's this disconnect between JavaScript land and browser land. So the browser's running, you know, as a whatever, you know, privileged C++ type, you know, app, and then the JavaScript is influenceable by the website to the user, right? And there's a disconnect in terms of how they operate. So what usually happens is there's some function that gets passed, you know, like an object, and that object goes off the JavaScript land, and it may come back freed, and the actual code that was using that object doesn't realize it got freed when it was out in JavaScript land, and it tries to use it again. So it's a use after free. It tries to delete it or, you know, operate on it, or just, you know, do some method on an object.
Which side's trying to operate on the JavaScript
The
side?
browser side.
The C.
Yeah.
Or C++.
So the browser, you know, says, oh, here's some pictures to display or something. You know, those are like all pointers to objects or something, right? And then gets them back and says, well, I better free those now. They've been, you know, displayed or whatever, but they already got freed somehow in JavaScript land accidentally somehow. And it blows up and it tries to do something, but it might get them back. So that's kind of the, I mean, there's probably a million different ways you could come up with a use after free bug, but that's kind of the typical scenario as it relates to browsers. And so a picture of that is something like this, where you've got object A, and then somehow that gets freed, but there's a reference maintained when there shouldn't be. And then the attacker, and this is the reason why they tend to be exploitable, because while you're off in JavaScript land, the attacker can do all kinds of wonderful things, like allocate memory and all this kind of stuff, right? By using the JavaScript method new, you can fill that hole that's now gone with your own stuff. So that when it gets back to the browser, it tries to do method B on A, but A is pointing now to attacker-controlled data. So it not only blows up, but it may not blow up, right? It's the worst scenario. It may actually run a working exploit. So that's kind of the general. And that's made tricky these days, right? Because it's not like the old school attacks where you could just like overwrite a return address and jump back up to the stack and run code like old school stack buffer overflows. Nowadays, you've got that, which protects the stack and heap, right? So you've got pages marked as non-executable. And then you've got ASLR, which randomizes the load location of all the DLLs as well as the base executable itself. So what an attacker needs to be able to do is all three of these primitives, basically. It needs to read first to leak some memory, and it needs to write, which is to change something, and then it needs to redirect, hijack the flow of execution. So it needs a read, a write, and an execute, basically, to sort of defeat modern day protections that are in like Windows 7, Windows 8. And, you know, you could go find as many CVUs as you want. There's been plenty of them as it relates to use after freeze, but I thought I'd throw a couple up and give an example of one. So this is, you know, we don't have time to go through all this code, but this was from WebKit. It affected Chrome, and it was in this file called html_element.cpp, and it was in this function called setOuterText. And really the problem, from a nutshell, so to speak, is that there's this mixing. Sometimes they use these safer versions of pointers called a reference pointer, a ref pointer. There's sort of what's called a smart pointer, so the deleting of the object is managed in some more abstract way, so the programmer doesn't ever have to worry about freeing objects, and that tends to be helpful. But they mix them with native non-reference pointers as well, so you're kind of mixing and matching. And that's not really a good thing. And the other thing that makes these sort of hard to spot is that, like, this function here, this append data, you might not know that if you were just happen to be auditing this code, or you're like, what happens is these developers, they end up in their own domain. Like, these guys write the JavaScript portion, these guys write the browser portion, and they don't often intermix or something like that, right? And so when it all gets put together, nobody thought of the fact that, oh, when this append data is taking a non-reference pointer from browser land, and that can actually get freed in JavaScript land. So when it comes back and tries to operate on it, then, that's where we might have our use after free situation, right? So that's kind of as I said before, that's kind of the typical, and this was actually a real exploitable bug. It was an issue. So this is not a contrived, I guess, example. And the fix, in that case, what they did to fix it was basically two things. They changed the function all around in general, but they mainly, the biggest changes were they used reference pointers all throughout instead of mixing and matching. And then they also check when they return with this text next object was the problem. They check to make sure it's valid before they try to operate on it. So they kind of like, I guess, what you would call defensive programming, which interestingly enough is kind of, it's been a coworker of mine with some developers. We've had some interesting debates on that because a lot of the developers that believe in sort of like clean, they have this idea that they can write clean, perfect code. And so they're like, well, if I've checked it once, or, you know, in other words, if I'm using reference pointer, I'm doing the right thing to begin with, then I shouldn't have to do this check because we're covered. Like, I'm only going to do the right thing once, and that's it. I'm not going to like put in extra checks all over the place to like check it again just to make sure. And our counter argument to that is, yeah, but that doesn't seem to work very well in real life. We've seen way too many cases where people, for one reason or the other, just can't write perfect code. You know, they try, and it seems like it works for a while, but then something happens, and a function gets changed, or an API got, or a library that it depends on, or who knows. So it's better to two things. A, have a few extra checks, be defensive in your program. B, put those checks as close to where the potential problem is as possible. And the reason for that is it helps auditors. So when we're looking at the code, we don't have to go back a million functions and files to find, oh yeah, this size is actually checked, but it's like way back here, and it took me 2 hours to find. Or if there was a link check or something right before the mem copy, or if there was something close to where a dangerous maneuver is being done, that helps me go, oh, it's safe. I can tell right here, at least it's safe, because they're checking it right before they do this. So that's kind of the advice that we sort of hand out on that note. Another example that's been pretty popular, Windows had got really blown up with this early in, I guess, 2013. Really, they had there was a lot of kernel patches that came out. There were a lot of kernel exploits that came out. There was a lot of issue around the kernel, and a lot of those were related to this bug here called the double fetch. And basically, in a nutshell, that's just where I think I have a picture that goes along with it. You grab something from user land, and once is okay, but then after you check it, you grab it again. So you fetch the same thing twice. So between here and here, so you're checking it maybe, or maybe you're not, but either way, you're getting some value twice. It was okay once, but then right before it's actually used in a security-sensitive operation like a copy, you go ahead and grab it again from user land instead of grabbing it once, storing it in a local variable in the kernel, and then always operating on that local variable. So you should never be doing a double fetch. There should be a single fetch for every user land parameter that comes from user to kernel. Basically, is really the problem. And it's kind of in terms of, what older people have called these time to check, time to use, race conditions. all these different terms that are kind of related to it, but double fetch is kind of the term that's being used for this category bug. And there was, yes?
The static analysis would find that.
Probably. I mean, you would hope so, but
Yeah.
I don't think so. Yeah, I mean, because I know Microsoft uses a lot of static analysis,
Yes,
and they
static may
got
not find it
destroyed
because,
with this in
syntax,
this past year.
that's more a logical issue, right? So static won't find it really because
So that's code
syntactically,
review?
static code review may not, like code review may, but like an analysis tool may not because
Yeah.
for it it's, you know,
It's fine the first time and it looks
Right.
looks fine the second time. Because it parses through it.
Yeah, maybe they're building better rules for them now that, I don't know if I have any of the compiler examples with me, but I've seen some versions of this that are even worse, that like you literally can't see in code. The compiler actually introduces a double fetch based on the line you wrote. Like you wrote one single line that looks good, and the compiler, when it actually compiles it, it uses like 2 assembly operations and grabs it twice with a time sink in between. So there's even worse versions of this that I'm not showing here, but yeah, there's some frightening things along this line that really hurt this past year, I guess, for a certain large company. And basically, the way the attack works is, again, assuming that this is how the compiler generates the code, you're grabbing it once, and in between that time, the userland attacker starts some spin on that variable, racing to try to change it before you grab it again. And usually you can win that race because you've got multi-core OSs and you're spinning that in a tight loop. So that's a race you're probably going to win. And then the next time you grab it, the value, instead of being 1,000 when they allocated memory, now you changed just one, the most significant bit to be like a really big number. So when the copy happens, everything blows up. So that's kind of the way that works. And just to show, I guess, another example of it, fetching twice, bad. Fetching once, good. And so the way you make it good is you grab it in a local variable, and then you use a local variable twice instead of grabbing it from memory twice. That's the fix, basically, is to always, in kernel, if you're writing kernel code, you should always be like grabbing that and pulling that in as a local variable. But again, I think the reason these kind of things happen because a lot of programmers kind of have this purist mindset of, well, I don't need a local variable. I already have a reference to this, this variable. I'll just use the same reference over and over again. Why should I copy it to another local variable? Like it doesn't make good sense until you understand the bug, and then it's like, oh, I see why I need to do that, right? Yeah. And so it's easy to see how these crept in. Okay, so the final piece of the kind of moving toward a conclusion, the final piece of the SDL is this sort of response. So if somebody wants to report a bug, like I found a bunch of crashes in Word and I want to give them to secure@microsoft.com. Big companies mostly have this process really well defined. They have a whole SDL team here at Microsoft and a whole group of people. I know a bunch of them that deal with all this stuff. But a lot of smaller companies don't, that are just kind of waking up to the security issue. They don't have a security@company.com, and they don't even know, if I started it, who would be the one that should get those emails, and what should they do about them, and should they call the lawyers and try to sue them? That's what the companies used to try to do, by the way. I actually had that happen to me many years. A lot of other researchers in the field had that happen a decade or so ago. You'd go to report a bug and you'd say, hey, I found this bug and I want to let you know about it, and they send you back a letter saying we've contacted our lawyers, we can tell that you're trying to hack our product, and so we're going to sue you. And it was a really bad situation for a lot of researchers out there. So that's gotten better. I think over time, companies kind of know that they need to treat researchers nicely, or that they'll all sort of get huffy and
Come back and hurt you.
come back and do crazy things. I'm reminded of a certain anonymous attack against a certain small company named HP Gary, but that's a story I won't go into. Anywho, so have a plan for that. And then in terms of trends, SDL, this idea of having a continuous maturity model improvement, I think it's caught on. A lot of the bigger organizations are getting it. There's less sort of lane bugs. You don't see, like the simple stir copies in code like you used to in current code. I will say I have seen some large older companies. A lot of companies have been around for 100+ years, especially big companies that are in oil and gas and defense and stuff like that. And they have code from 40 years ago still running on, let's just throw out an example of satellites They just, the knowledge of all these different kinds of hacks and attacks and stuff wasn't there then. And so, even though the SEL's caught on for new code, I would say beware of legacy code. And the other thing that's kind of working against us in terms of security is the growing complexity. So, like, even though current writers of browsers, whether it's here at IE or Chrome or Firefox or whatever, they know about all these attacks. They're super well versed in every kind of use after free, buffer overflow, EPO, all these kinds of different memory corruption bugs. They know all about them, but the code is just so doggone complex, and there's just nothing you can do about that. So the code is just super complex when you look at how hypervisors are written and browsers are written. So C and C++ really shouldn't be getting used on like the majority of new apps being written, right? The majority of new apps written should be in .NET or Java or I don't know. I would prefer C# over Java any day, but some managed language so you don't have as many memory corruption errors, right? But you just can't use it for certain things. Kernels, embedded systems, browsers, they still are and they still will be for the foreseeable future written in C and C++. So, and they're growing in complexity too. That's the interesting bit. So, one of the things that's interesting in terms of a trend that I've seen is better analysis on why bugs were missed. So I was asked by some colleagues of mine in the research industry, like a guy named Richard Ford down at FIT in Florida. He asked me to help co-author an article on why the heartbleed bug was missed. If fuzzing and static analysis and manual, if all this stuff's being done like we think it is, why did that bug creep in? And so that never used to happen so much. There wasn't so much analysis on. There was just so many bugs and so many things that people didn't have time to slow down and think about how did that creep in, why wasn't it caught testing and stuff like that. So that's the other thing that's some of the good news, I guess, in terms of AppStack is people are starting to try to slow down and think about why didn't we get this or something? How could we?
Time check, because I noticed Phil left, so I wasn't paying attention to time either. So
Yeah, I'm probably going long, aren't I?
Right. Let's.
Yeah. So
You did.
sorry about that. I think I'm almost done. So that was all I had actually. Good timing on that in terms of the technical content. So in terms of trying to tie that into analogy and the gospel content, the way I look at it from a full gospel message is kind of the original control flow hijack when the serpent convinced Adam and Eve that there was a better code path, there was a better execution trace. That's kind of, so that's sort of, the beginning of the end, so to speak, on the original code flow. I'll wait for Anna, he's taking a picture back there. Yeah. And then in terms of what I call SDL, for us, for Christians, we have a securely developed life. We can overcome that original code flow error by accepting Christ and sort of getting our life towards eternity back on track. And then we're set free. We don't have to worry about all the problems. We see a lot of crazy things in the world, right? All this, whatever it is that you're facing, whether it's just sinful thought patterns or, I don't know, wacky government controls or all this crazy stuff you see in the media and in the world around us. We're sort of like, we want to help make that better. We want to do the right thing by taking care of, our families and the widow and the orphan, doing all the things that God's called us to do, but we're not worried about it. We don't have the same level of depression and anxiety that so many of the people in the world are chained down with, right? Because we've been sort of free from all that. We know we're already seated in a heavenly place. We already have an eternal destination in mind, so we don't have to be so chained down. But what happens, this is where I try to get in the whole double fetch, lose after free thing. What happens is, even though we originally come to the Word with joy, so many of us, we keep checking back and we go, well, they're teaching this now in school, or everybody else is doing this, or it's now commonly legal to engage in all these kinds of activities that are now legal, or whatever it is. And so we have to make sure that we're not going back to the herd when we've already received the Word. So that's kind of I try to tie it in with the double fetch, lose after free. I'm not so great at that sort of analogy sort of thing, but all I know is that when I've made it in my life about me, it wasn't so good. It was not good. But when I've kind of tried to organize my life around my family and other people, and that was better. And then of course when you give everything you have for God's glory, that's the best, and it's the only thing that leads to a lasting peace, I guess. So to try to wrap it all back around from the beginning, would drawing people closer to the Father actually make software and technical systems more secure? I think it would, because you wouldn't really, there'd be a lot less malicious activity. There'd be more people, trying to make things better instead of trying to make things worse. I think it would make the whole world better. And best of all, you'd have more of your family and friends with you in eternity. So I think it would, is kind of how I wrap that around. And I've got my contact information there. I had some bonus material that in case I ran short, but I think I ran long, so I think I'll skip the bonus
No, you're
material.
good. We have
and,
like another 2-3 minutes, but unless people have to leave, but we can take about 5 more minutes. And if people have questions, we usually leave this time for like question and answers and
Okay.
any points and observations. So if anyone's got any questions to share, then feel free to ask.
Questions? Perfect, clear as mud.
What's the, one of the things that you brought up was the whole browser issue and with, using, it seems like, one or the other is better, but it seems that there's, from source guidance to securing or, configuring browsers to avoid some of this stuff.
Right. So browser security, I guess, is the question. That leads me to my bonus material. I'm glad you asked that question.
Straight man.
Ham.
So, in terms of user land protections, like EMET, those are good because what they do is they force exploit writers to kind of up their game. But they're bypassable because, like in the case of EMET, it's a DLL that runs in the browser's process space. So the prevention and the attack are running on the same plane of execution, so you can bypass that. So I say stuff like EMET is good, particularly in the fact that it's free. It's good. I say kernel protections are even better. So like there's other products out there, like Chrome has a sandbox, for example. I think actually the newest version of IE uses sandboxing-like technologies where basically all the tabs of the browser are either running as some low privilege process or they're in some sort of restricted environment such that you basically either need a kernel exploit or you need 2 exploits. You need like the original browser exploit and then you need like a browser sandbox escape exploit to kind of get out of whatever like sort of main environment you're trapped in. But unfortunately, both of those have been fairly prevalent this past year. There were a number of kernel exploits which get you out of all these kind of kernel protections, and there were also in the case of Chrome there were some attacks demonstrated at like Pondone and CanSec where they were able to they didn't even have to use a kernel exploit. They were able to exploit the browser and then the master-slave relationship that the sandboxing technology had set up as well to get out of it. So I say that's better. There's good, better. So all these are better than nothing, right? There's good, better, and then of course I have to pitch this a little bit since a certain company I may or may not work for has a technology that revolves around hypervisor protections. But security through isolation is kind of a new idea. It's a startup company type idea where basically what if we didn't sandbox, because if you sandbox you're relying on the security of the kernel, so the operating system is still the lowest common denominator in terms of security. When you add a hypervisor into the mix, you're basically saying, what if I actually ran every tab in IE in a separate virtual computer? And the user wouldn't be able to see this if the technology was so fast and so well done that to them it just looks like they're using IE. But actually every tab is a separate virtual computer, so you would need a browser exploit, and then whatever other browser exploit you need to get to the greater system, either a kernel exploit or some other sandbox-like exploit. And then on top of that, you would also need a hypervisor escape or a hypervisor exploit to actually get out of the hypervisor as well. So it would give you one more, you'd need like 3 things chained together instead of 1 or 2. So that's my take on it. Other people may have a totally different take on that, so I'm not saying that that's the advice for you, but you asked, so.
Mm-hmm.
Is that typo? It's micro VM? Or
Yes.
Making sure.
Micro. We actually use a little lowercase u. We use the terminology of coming over for UVM. Because it's a full VM, but it's done in a way that's like super fast. Because it wouldn't work in reality to have, like if you just tried to use like VMware Workstation and start like 50 copies of your operating system on your laptop, it would bring it to its knees right away. But we can actually do that with this technology.
To the cloud.
VM.
Yeah,
Yeah.
right.
Yeah, we can actually do that and have it work quite nicely with reasonable overhead. So
So I've got a quick question. You
Yeah.
mentioned about, towards the end you mentioned your slide talk about testimony, but
yeah.
can you share a little bit about your just your faith background.
Okay, sure. Yeah, I can talk about that. So I guess the question is, what makes me want to pay for my own flight out of Michigan today and come all the way down here when I could be like having the day off barbecuing in my backyard or something like that,
Yeah.
right? It's a good question, actually. My wife was sort of only semi-convinced that this was a good idea for me to use on a day off too, by the way. So I mean, it's a very relevant question. What drives us as believers to basically go, essentially way beyond what the world would go? Because generally the world's not going to go out for something like whether they're not getting, like there's essentially potentially no benefit for me to come do this, right? I'm not getting paid. I'm using my own time and money. What drives me to want to do something like that? And I don't know. I mean, I guess mostly saved at a pretty young age. So I've always known that I needed to be close to God. I've had 4 brothers. My dad actually told us when we were young that we would grow up to be mighty men for God. So I've always had that sense and that family legacy that God was with me and that He was going to use me to accomplish things for His kingdom that had nothing to do with the things of this world. So I guess that's it in the short term. That's probably the most concise answer. I've had my ups and downs in life like everybody else. The typical kind of falling away in college and having to recommit my life. Once I was married at a young age and kind of, I've been married 16 years now and I'm 36. So you get this, I was married pretty young. So that was quite a challenging time in my life and stuff where my wife and I had to figure out if we wanted to be serious about our faith or if we were just going to, kind of divorce and scratch the whole thing and just live our life for ourselves, which I think is the natural temptation at that age. But we decided to kind of continue in this vein of committing ourselves to what we felt like was more important than ourselves and our own time and stuff. So I don't know if does that answer that. It's kind of a winding answer to that question. I guess there's no wrong answer when somebody asks about your testimony, right? You can't blow that. It's like the one question you can't. Yeah.
Good.
Any other? Yeah.
As far as the JavaScript goes, recently, the past couple of months, there's been like a lot of demand for JavaScript developers, and then there's just a big push in that area. The thing about the JavaScript engine, though, is that it's baked into the browsers, and each one is very, very different, and so the exploits are all very, very different. What do you see happening in the future for that?
It's a good question. I mean, so those sort of technologies are very, I'll call them pretty low level, right? They're pretty tied to the performance of the particular browser, and who knows, maybe even have some specific hardware accelerations, or like to really, they're trying to squeeze the most out of they can out of the browser, right, for performance reasons and stuff. So that lends to that scenario of things being very particular to platform. I remember talking to a guy a couple years back about there's going to be some new big programming language that's going to allow you to develop web apps for like any mobile phone or whatever. Like you can develop in this one generic environment, it'll work on everything. And the problem with that is it won't work very well, right? Because to really get the most out of your device and stuff like that, you need to be down, you need to be lower down, you need to be more intimate with all the system APIs and that kind of stuff. And I think it's kind of the similar thing with JavaScript. It's like to really squeeze the most out of your website, your browser, and your situation, like you've got to get down in the weeds, and it leads to some interesting compatibility issues and some interesting security issues and a lot of work for JavaScript developers. So I guess if you're in that field, you've got a nice career ahead of you. Likewise in security and all the other technology fields, right? There's no shortage of work. But yeah, I don't know. I don't know that they're going to standardize anytime soon, particularly with some business competition there as well. I think that's sort of unlikely, but maybe we'll see.
I think there was an attempt like by OWASP a couple of years ago to bring all the browser developers like Mozilla and Internet Explorer and Chrome, all these guys into the same room to see if they would ever agree to standardizing, and then but I don't think much came out of it other than they all got together in one of the OWASP conferences. So there may be some stuff out there that I don't know. I haven't heard anything about everybody wanting to play together, so which is a necessity, I think. So
I have one more question, prompted by the latest flaw in OpenSSL. From the standpoint of interface between the browser and the servers and providing identity and encryption protection for your session. Any thoughts or comments on that?
Well, I mean, we always tell developers as security people not to roll your own crypto, so I'm not sure I want to roll my own answer to that one. That's a crypto, yeah, please say like if you're coming. That's definitely a crypto type question, right, or an architectural question in terms of is there some better way to do PKI? Is there some better way to do certs on pre-installed certs and
Yeah, because OpenSSL having problems, and
yeah.
you know, what are the other choices? I guess.
Yeah, it's interesting too, this whole OpenSSL thing, that prompted a lot of people to really reevaluate their thoughts on how good open source software was. Because, you know, originally before it was like there was a big push to try to like say, hey, everybody's got eyes on it, so it's open, so it's definitely better than closed.
Yeah.
And now people are starting to think, well, maybe if everybody has eyes on it, nobody has eyes on it. They're just assuming somebody else is doing it, right?
Yeah.
Which I think is partly what was happening there. So, I mean, I don't know that that's a whole different can of worms that I don't know that I have any authoritative answers on all that.
So just so you know, July 11th, I'm trying to build a proof of concept to demonstrate OpenSSL exploits and kind of tie it to our Hackfarmers talk. So that may be the topic. That will be, so what does it mean? Kind of, I think, trying to look at part lead and how how that ties into our team security and enterprise. So OpenSSL, I think if you guys think that would be a good topic, then I may just work on that.
Well, it's important.
Debating, yeah.
Good or not, I don't know, but it's important.
Right. Interestingly enough, I think with the patches that have been done to the OpenSSL framework, the attack vectors are now changing to exploit other like wireless and other technologies to still exploit it. So it's interesting to see other attack vectors come up. So you may have been patched, but there may be like EAP may be weak on your implementation, and that may be the route in against the patch system. So we'll see. I'm still building that proof of concept at the end right now. So.
Yeah, that sounds good.
Yeah, Sam has done anything out of it.
Has it?
Yeah. Thank you.
Anything else? We can close, and then Jared is going to be here. So I mean, if you want to chat with them a little bit after this talk as well, make sure you guys grab some stickers if you want, and we'll go from there.
Cool.
Thank you very much,
Thank
Jared.
you.